Now I'm just starting up my screen sharing. So hopefully on all your sides, you're able to see what I see. And what you're seeing in the background here is the user interface for our i-Dixel software. Now, this home screen, as we call it, is basically the list of patients in your database. As you can imagine, we've anonymized everyone, so the names of our patients are very much machine-centric. So definitely not what you're going to see in an actual practice, but nonetheless, for illustration purposes, this will be enough. Now, when we are going to search for patient data, we can, of course, search here in this bar at the top, either by patient ID, if you're dealing with, say, for example, a medical ID, or, of course, by the patient's name. So now if I was to search, in this case, by name, my patient's name, strangely enough, is 100 by 80. If I go ahead and search that, it's going to filter down to patients that match exactly what I've typed. And the one I'm looking for in this case is this X700 endo case. Right? So to access the image data for any of my patients, I simply double click my patient. Now this is going to bring us into the patient folder. Now this folder is where we keep all of our images. Right now, very, very boring and simple because this particular patient has one single CT data. This patient could in the future have additional images, including intraoral or even panoramic images, but in this case, as I said, we're focused on cone beam CT. So I'm going to select my image and I'm going to click our 3D viewer button, and this is going to go ahead and launch our 3D viewing software. Now, depending on the speed of your computer and the speed of your network, this volume could take a little bit of time to load, but this is all local, so it's relatively quick. And this is what you'll be presented with the very first time that you look at and open i-Dixel. The same thing will happen if you were to, say, acquire a volume with your cone beam unit. This is exactly what you'll see as a result. Now, the very first thing I always do with any image is adjust the contrast. There's no point to start reading and manipulating an image if you can't see the detail in that image. So looking at this screen, you can see it's a little bit dark and a little bit gray. So what I want to do is kind of adjust the contrast to kind of pull out details, including the hard tissues as well as soft tissues. And there's several different ways of doing that. And this is going to be a theme of the i-Dixel software. There's no one right way or wrong way to do anything. We try to provide you as many options as possible to make it easier for you. Now, the most technically advanced, of course, is to use this histogram window, which you can see here at the bottom of my screen. I'm going to go ahead and switch this over to my log view because I want to see a little bit more detail beyond what the histogram is currently showing me. If I show the log view, I can now see a little bit more detail out here in the left side. This is basically soft tissue and air, and over on the right side, which is your hard tissue, your dentine, your enamel. Now, most endodontists will recommend it to take this center line here and move it over to the first peak just before the primary peak of your histogram. It's almost always like this when you look at a histogram on your screen. The horizontal line, most endodontists recommend to set it down to just when the histogram starts to level off, somewhere in this range. And from that point, they grab this white line here, this angled line, and they simply pull it up until it has the detail level they want. Okay. Now, this can be shifted forward or back by simply clicking on the vertical line. And for my particular monitor, I'm going to put it about here because that's what I like. Again, your monitor will be a little bit different. Now, as I said, there's more than one way to do this. This, as I said, is the most technical. On the right side here, this tool panel, down in the filter section, you'll also see a brightness and a contrast slider bar. So I can go ahead and adjust just the same way by dragging these bars. So if you come from an imaging background where you had brightness and contrast sliders, you can of course adjust them by using these sliders. And for shortcuts or for very minor adjustments, you can do all of this work as well by right-clicking and dragging with the mouse button. Now, this is something I use for a very quick adjustment, usually if I'm zoomed in or if I'm looking at a particular slice or cross-section. I may want to make minor adjustments after the fact. So dragging up and down changes the brightness, and dragging right and left changes the contrast, which is essentially the window at which I'm looking at. You can see the window change in the histogram. Now, when I'm finished with adjusting my contrast, I usually want to just get this histogram window out of my way, because now the images are adjusted and I just want to focus on the actual image data itself. So this button up here that you can see is highlighted. I'm just going to click this, and that's going to hide my histogram view. If I ever need it back, of course I can click it again and bring it back. So it's just out of my way. Now, I always recommend to our doctors who are using our software to bookmark this data. There's no point to make all these nice adjustments to the contrast and then have to do it each and every time. So of course you can save this at any time during our discussion, and I always recommend to do so immediately after adjusting the contrast. So down here in our tools, I'm going to hide this filters now because I don't need it. You'll see a section called Files. Now, there's a button that says Save Images to the Database, and this is what I want to do. I click this, and I want to save this current state, basically what I'm looking at right now. Okay, it's going to pop up this dialog with a little name, and I'm going to actually give this a name because I want to remember exactly what I actually saved. So I'm just going to say contrast as a quick reminder to me that I adjusted the contrast. And you can see that that's going to be saved into the database. And now I can go ahead and proceed. So with i-Dixel, what I usually do is recommend that a doctor, especially with a large field of view like this, to focus on the maxilla or the mandible, depending on what you want to look at. In this case, because it's a large field of view and it's also maxilla and mandible, we're going to have to look at both. So I'm going to start by looking at the maxilla. So I'm going to grab this red line here, and I'm going to move it up into around the bony structures of the maxilla, okay, somewhere around the apex of the teeth. Okay, and you can see when I move this red line that the axial image over here in the top left corner of my window has changed. Okay. Now, in order to save time, what I normally would recommend someone do is to look at the cross section showing as much bone as possible. So this green line, if I move this over, you can see it's going to move the coronal view. Okay? Now, if I want to see more bone, I really want the angle to be along here. So in i-Dixel, what we do is we simply grab the image and rotate it like an object. So I can imagine just me grabbing this corner and just dragging it down. Okay? This is going to align the bone with my line. And then I'm going to start from one side and just work my way back towards the buccal side of my volume. Now I can do that, of course, just like you saw me, by grabbing this green line and moving it slowly over here. But because I'm looking for fine detail and I really want to get a good overview, I'm going to do this by using my scroll wheel on the mouse. Okay? On the bottom right window, if I hover over this window, I can use the scroll wheel to do exactly the same thing. And I'm going to slowly go through my image looking for pathology. Now, a few of you may notice that this particular person does seem to have an endodontic problem over here. And we're going to come back to this in a moment. But for now, I want to scroll through and see what other issues we find. Of course, here as well, we see a massive caries. Whether this tooth is savable or not is debatable. I would imagine not. But nonetheless, we will again go back to that. But let's take a look at the rest of this part of the maxilla and see if there's anything else that pops out to us. Again, this is just my quick initial overview. Now, as I'm starting to move towards the patient's anterior, I really want to see the detail around where my mouse is hovering. So these lines, of course, I can get out of my way. Up here in the tools, there's a view button and the option to show or hide the positioning cursors. So I'm going to hide those. Now I can still, of course, grab them and manipulate them, but they're just sort of out of my way for the moment while I'm examining this particular patient. So at the moment, I don't see anything else that's jumping out at me. So I'm going to make a mental note to come back here and take a look at this. In fact, instead, I'm actually going to mark this. Rather than make a mental note, I'm going to let the software take care of this for me. So I'm going to circle this as a reminder that this is an issue that I'm going to have to take care of. So I'm going to go over to my measurements and overlays, and I'm just going to grab a circle tool and circle this region. Again, it's fairly obvious in this case, but it's just a reminder, a quick way for me to come back to this particular issue. I'm going to click back on my Select Objects tool so that I can continue to rotate and manipulate my volumes. Now, on the same way, I'm going to move this green line over to the opposite side of the maxilla. And once again, I'm going to rotate my volume such that it lines up with that green line that I've just moved. Why am I choosing the green line? No particular reason. You can always use the blue line as well. It doesn't really matter. It just comes down to personal preference. Now, starting from this side, doing the same thing, I notice immediately that we have a supernumeracy. Again, this I might also want to annotate. I could circle it, or this time, I think I'm just going to put a simple arrow to mark it, like so. Now, once again, going back to my Select Objects tool, I'm going to continue to work my way through here, again, looking to see if any other pathology comes out. And you can see here, of course, another case of extremely bad caries. Now, let's say in this case, I want to look at this in a little more detail. So this is a very large volume. And sometimes, depending on the size of your monitor, it can be difficult to look at a particular individual tooth in a large 10:8 volume. So we have a couple of options in i-Dixel. If you just want to have a quick look at this particular image, I can shrink or expand this image by grabbing this frame in the center of my screen, and I can just drag it up like this in order to make it larger and make it jump out. The functionality remains exactly the same. I'm using my scroll wheel to scroll through. But if I really want to see this tooth in deeper detail, okay, I'm just going to focus right on this one. Let me bring my lines back so I can line everything up. So I'm going to quickly move this blue line over to this tooth, and I am going to rotate this image to line up with it. Okay. The reason I do this is if I want to do any measurements, I'm trying to avoid what's called parallax. Now, for those of you who haven't heard the term parallax, if you can imagine very basically cutting a carrot, all right? If you cut a carrot directly in half and you look at that carrot, it's going to look like a nice round circle. You know, it'll have the root in the center and no distortions. It's just a nice, beautifully round circle. But if you went ahead and cut that carrot at a 45-degree angle and looked at it that way, it's not going to be a perfect circle anymore. It's going to be more of an oval. And the same thing is going to be true of your cone beam CT. If you slice an image at an angle like this, you can see this tooth here actually elongate, okay? So for example, if I measure this now using this measurement tool, this is end to end about 16.83 millimeters. But if I straighten it up, and I again go end to end, 13.1 millimeter. So you can imagine if you are going to be measuring for an implant or you're going to be doing any measurements whatsoever, you really want to take the angulation of your image into account before you do your measurements. The easiest rule of thumb is just to make sure everything is at 90 degrees. So rotate your volume this way to get the bone at 90 degrees, this way to get the tooth 90 degrees, and in the same way, we're also going to rotate our image here to make sure that we are looking at everything 90, 90, 90. This way, we're going to avoid that parallax and make sure that our measurements are accurate. So as I said, again, I want to focus on just this tooth. So I'm going to use a small tool that we've developed that lets me zoom in 3 dimensions. This tool here, the show or hide FOV region, this is our zoom box. If you click this, you'll see a large box get drawn onto the screen. Now, I can adjust the box size by clicking and grabbing its corners. And I can also, of course, manipulate its position by grabbing these lines. When I'm happy with the positioning, I'm just going to double click on the edge of this box right where my mouse changes. When I do that, it's going to zoom in 3 dimensions. And why I want to emphasize in 3 dimensions is that I can actually go in here and now rotate this independent of the main volume. So if I have a particular case where I suspect there's some potential endodontic problem, maybe a root fracture, something that I want to get some more detail about, I can zoom in on it this way. Now, if I find I've zoomed too much or not enough, I can still adjust this window by holding down the control key on my keyboard and right-clicking and dragging. So if I drag down, it's going to zoom me out. And if I drag in, it's going to zoom me in. Okay, so I can always make minor adjustments while I'm in here. Now to pop myself back out and look at the larger volume again, all I need to do is double click anywhere on any of these images, and it just goes ahead and pops me back out. All of these annotations that I've made, including those arrows and circles that I did earlier, those are stored down here at the bottom of the screen. So if I roll up any of these tools to give me a better view, let's say, for example, this tools panel here, then I can see the list of all my annotations. I've created a zoom box, I've created some circles, and I've created a couple length measurements when we were talking about parallax. Now, in order to show those annotations again, and you can imagine right now, it would be difficult to find if I just rotated and worked my way through my volume, I just double click any of the annotations and it's going to bring me right back to the slide where I made it. This is the arrow that I put in. And of course, this one here is the circle for that particularly nasty caries that's over here in the patient's left side. Now, you can see this square, this zoom box is starting to get a little bit distorted. So I'm just going to go ahead and hide it. So this checkbox here allows me to turn off any of my annotations. So if I turn that off, now it's out of my way. The data is stored, but it is off of my screen and out of my way. I can do this with any of my annotations. Now, in the same way, I want to view the patient's mandible. Now, of course, I can painstakingly readjust and rotate and get the images back to where I started. But if you remember at the beginning, I saved this state with the contrast adjusted. So the way I get this back is to go over to my data screen. And you can see here down at the bottom under data, a list of all of the states that I've saved. Okay, I've only saved one at the moment, which I called contrast. If I double click this, it's going to ask me, do I want to save the current state with my annotations? And for this time, I'm going to say no. Now it's going to put me right back to where I saved with my contrast adjusted. I don't need to go back. I don't need to make further adjustments. And now I'm free to begin looking at the patient's mandible. So once again, I'm going to bring up my main tools and since I rolled this up, I'm going to expand it, the tools section, because I want to use this later. And I'm going to move the red line down into the patient's mandible. In the same way, I'm looking along the bone. Okay, so once I can see the bone here in my axial slice, then I'm going to move the lines over and rotate my image so that it lines up. Again, the only reason I'm doing this is to save myself some time so that I can see more of the patient's mandible in one shot. And now, like I did with the maxilla, I'm going to focus on this part of the image only, and again, scroll my way through looking for pathology. Now, as a quick view, I'm going to get my lines out of the way. Use this quick view just to highlight this seeming endo problem. So in this one, I think I'm going to stop for a moment, and I want to look at this tooth in a bit more detail. So like I said, I would like to get this at 90-degree angles, right? So to get my images back to the center and the same size, I'm going to double click right here on the center, and that's going to pop my images back to their standard width and position. Now, I want to move the green line to around the center of the tooth and line it up. And let's bring the lines back just to emphasize this very clearly. And in the same way, I want to grab this and line it up. Now again, going through this tooth, I want to see how serious this particular endo problem is, and if the patient has any additional problems with this one. Now, in the same regard, I will do this on the opposite side as well. Now, I'm going to leave that as an exercise. I'm not going to do this at the moment, but you can see the general approach that I would take in looking at any cone beam CT image. Now, one of the things I'd like to do if I was, for example, going to look at implant placements is I may want to mark this nerve canal. You can see here at the bottom, it's rather clear on this particular patient, and this is somewhat lucky. Not every patient will have a perfectly clear nerve canal. It will depend heavily on the X-ray exposure parameters that you've set, and potentially it'll depend on the actual patient's jaw structure. It doesn't always pop out as clearly as this. So the quickest and easiest way to draw the nerve canal is to select the tool here. This is our nerve tool. And find the end of your nerve canal and basically trace it along, clicking point by point along the canal. I prefer doing it in the XYZ view as a quick overview, but you can do this in multiple views, and we'll take a look at that a little bit later on. Now, to mark a point in our nerve, we right-click once to put a point, right-click again, and again, and again, along the canal. Now, why we're using right-click is it allows me to still left-click and move the images around, either by grabbing this green line like before, or by using the scroll wheel. There is no right or wrong way. It's just up to your particular preference. And we'll go just a little bit farther right to the end here. And you can see on the 3D volume rendering, the nerve poking out of the mental foramen. Now, when I'm done with my nerve marking, as with any of our annotation tools, I just simply click on my selection tool to bring me back to active selection. This will let me make further modifications and manipulate the images. Now, I've been focused entirely on manipulating the slice images. Now, of course, we can do the same on the volume rendering. So if I left click on my volume rendering, I can move this around, back and forth, up and down. I can look at it from any particular angle I wish. Also from the reverse. And it just gives me a general indication of where my nerve canal is. Now, if I want to show or hide more or less of the bone, in the same way that I adjusted my histogram, which was dragging up and down and left and right to modify the contrast, I can do the same with the volume rendering. So if I drag down, for example, it's going to increase the amount of bone that I see. And if I go the opposite direction, it's going to remove the bone, leaving just the hard tissues and enamel, as well as the posts from this particular patient's endo treatment. Now, if I'm going to focus up here in the maxilla, for example, we did see initially with this patient that there was one tooth that was not particularly good and most likely would be pulled. Now, if I pop this back up to the maxilla, and again, rotate my images so that I can see that particular problem, there it is. I can quickly pop over to this by holding Control and Alt on my keyboard and single clicking. That's going to bring my cursors directly to this particular lesion. Now, if I wanted to explain to my patient what we're going to do as far as a treatment plan, for example, extraction followed by an implant, I can actually place an implant in this position and then show this to my patient so that they can get a better understanding of our treatment plan. So with this area selected, I'm going to go over to my tools again, and I'm going to click on the implant button. Now this is going to bring up a list of implants that we have available to us. Under here, you can see manufacturer, and you can go ahead and choose one of the manufacturers that we support. Say, for example, Straumann. And then you can see in here multiple types of Straumann implants. So if I stick with the bone level implants, you can see from here the identifier of the implant followed by its length and its diameter. So if I go ahead and choose a smaller diameter, or let's go with a 4.8 diameter with a length of 8, okay, something like this. You can see over here in the right a preview of that implant. Now, this is an upper jaw implant, so I'm just going to click on upper jaw. All that does, of course, is just flip the initial state of the implant. It has no other effect. And I click Create to place my implant into the volume rendering. Now, from this point, of course, I want to adjust my implant's position. So the quickest and easiest is just to go ahead and grab that implant and just drag it into the position that I want. I can do this in all 3 dimensions. So if I need to go a little bit forward or back, or left and right here in the axial image, I can make all of these adjustments by simply left clicking. Now, if I found the angulation is not particularly good for this implant, if you see below me, and I'm going to move the screen line briefly so you can see it more clearly, clicking the implant brings up its axis. So if I grab this axis anywhere where my mouse changes, I can go ahead and rotate that implant along that axis. So I can make a quick adjustment, again, move my implant over here, and you can see in all 3 views that it is moving. Now, if I need to very quickly get centered onto this implant again, I can just double click it, and all 3 of my slices will rotate to show that implant in the center. Now, let's have a look at this from your perspective. All right. If I wanted to see this implant in my volume rendering, Of course I can see it, but it's kind of through the bone and it's a little bit difficult for me to get a good sense of what this is going to look like in the oral cavity. So what I'm going to do is I'm going to remove the patient's mandible. I know it's very disturbing sounding, but we can actually do this using the cutting tools within the i-Dixel software. So the cutting tools are located down here in the tools section. If you click on this static volume cuts selection, you can see that we can remove the upper portion, this dotted line here, or the lower portion of the axial slice. And we can also remove the sagittal forward and back, as well as the coronal right and left, depending on whatever you want to select. Now, where is it actually going to cut? It's going to cut wherever we set this red line. So if I rotate my volume in such a way that I can place this red line in the middle of the occlusion, then if I remove the mandible, all I need to do is click on my static slice and click on the button that shows the dotted line below. Now you can see the mandible is removed. Now, why did it leave this part of the teeth here? It's because I'm at an angle on this side of the patient. This is why it's important to adjust the angulation. But for my purposes, I'm just interested in this particular implant placement, so I'm just going to leave it as is. Of course, I can always go back and make adjustments later. So looking at this now, I can see that I've removed the mandible, but the nerve canal remains. This is not particularly interesting at this time since I'm looking at a maxilla placement. So just like before, I'm going to go down here. I'm going to look for my nerve, and I'm going to just remove these. Again, I'm not deleting them, I'm just hiding them from my view. So now, looking more from your perspective, if you were doing a surgery, I'm just going to rotate this up, and you can imagine this would be the view you would see when you actually do an implant placement. Now I'm going to add a little bit more bone in this case, and I'm going to move this image around a little bit more. I want to zoom in on this. So I can zoom in, of course, using the scroll wheel, but then I'm zoomed in at the center of the oral cavity. That's not particularly useful to me in this case. So I'm just going to use the shift key to shift my image over and left click and move it. If I want to rotate it without changing the angle, I can just hold down the control key and rotate it around its axis. Now I can really focus in on where I'm going to place this implant. And I may use this as part of my patient explanation. I want to show them that we're going to insert an implant here. This is, of course, without the abutment, but at least to show them what our general treatment plan is going to be. So as you can see on the corner here, I have this little head. Now this head is our patient orientation indicator. It kind of helps you stay oriented so that I know I'm looking up from the bottom of the patient, looking at the maxilla. Now, if I no longer need this and it's kind of getting in my way, I can simply right click on my images and I go down to orientation indication position, and I can go ahead and set none, and that just gets it out of my way. So again, like I said, if you're oriented and you know where you are, there's no need to keep that orientation indicator. You'll see more of your images without it. So now I can show my patient what my treatment plan is going to be. I can make adjustments to that implant placement. And of course, just like before, I can go ahead and save this at any time. So if I'm happy with my implant placement and I really want to be able to come back to this again in the future, I can go back over to my Files section, click on Save Current State, and say implant. Again, the name is for me and my benefit only. You can name it whatever you'd like. or you can leave the name as default. It doesn't matter. This data is not duplicating the volume in any way. This is just saving a snapshot of what you're looking at here. So feel free to save as many times as you need for this particular patient study. Now, once again, if I want to cancel all of these things that I've done, I can, of course, go back to my info panel, and you can see here again, I've got Maxilla implant, which is what I'm looking at right now, and the original contrast adjustment here. But like I said in the beginning, i-Dixel has many different ways to do exactly the same thing. And one of the ways to find these hidden gems is to right-click on the images and take a look at the menu that pops up. If you look here, you'll find a dataset section, and exactly the same information is presented right here. So if I want to get back very quickly to my adjusted contrast, I just click on contrast and it brings me back. Now I'm going to make a quick adjustment to my orientation, and I want to show you what it may look like if we remove the maxilla from this particular patient. So I'm just going to very briefly rotate the patient here a little bit, tilting back to be more of a camper's plane alignment. And then I'm going to go back to my static cuts and this time remove the maxilla. Now in this particular patient, I know this information because I've looked at the scan many times, but if you wanted to show some of your findings to your patient, it's quite useful to be able to segment the images in this way. Now if I rotate down here, you can see on this side, I have two supernumeracies. Okay, so if I wanted to take a deeper look at this, I can bring my images down or bring my red line down into the mandible, rotate again, move my line over, and now I can view these supernumeracies as well as another, unfortunately, another endo problem on this particular patient. So if I was looking at a corrective treatment for this patient, I may be able to show them this very easily so that they can see what I'm considering to do if I was to, say, extract these numeracies if necessary. So one of the things that you can do with three-dimensional images is reconstruct two-dimensional images. Now here we've been focused entirely on X, Y, Z, your axial, your coronal, your sagittal. But of course, we can go ahead and look at a reconstructed panorama. Now, I want to go back to my original contrast adjustment again, which gives me my original orientation. So I can do that, of course, by, once again, looking at or accessing my data set and clicking on contrast, or I can click on this general orientation button as well and achieve the same effect. This one here, I can look at, for example, the patient's profile. And now you can see, of course, I'm still missing the maxilla because I haven't reloaded any data. All right. If I want to get the maxilla back, this handy undo button, undo last cut, will remove the last cut that I made and bring back the volume just as I saw it. If I was to reload the data, you would get exactly the same effect. If I wanted to see the reverse and see behind the patient, I can simply click behind the patient here, but I'm going to click on profile. This would be the general view of my patient. And again, I want to look at the maxilla, the mandible. Make sure everything is oriented the way I would like. And now I'm going to look at the curved multiplanar reconstruction, curved MPR. This is basically where we're drawing our panoramic curve and our cross sections. This is very typical of analysis that you receive from a radiologist. So if I click on this tool or this tab here, what you're going to see is whatever image I have here in this window is going to show up here. Just to make it very obvious, if I rotate it like this, it will again be rotated here as well. So I'm going to reorient very quickly and then go back to my curved MPR view. And I want to basically mark a spline, a curve that matches my dental arch. Now this arch is going to be different patient to patient, and also is going to be different depending on the orientation of your volume. So by clicking on this spline tool, I can now click single points along the curve. And again, I'm not looking for exact positioning. I'm just looking to get a rough position because I can, of course, adjust it later. Double click to end. And now it's going to give me a reconstruction along that arch. You can see in this panorama that some of those endodontic problems we identified earlier pop out rather clearly. And if I had my original nerve marked, it would actually show up here in the panorama as well. This line that's down the center, this is marking the patient's mid-sagittal. So basically, I want to set this to the center of the actual patient's mid-sagittal, which is about here. And what this is going to do for my cross sections is it's going to flip the cross section orientation once I go to the opposite side of the mid-sagittal. This is again just for orientation purposes. Now the cross sections here are in intervals of about 1 millimeter. Now this is always selectable, and you can choose to change that interval at any time by simply right-clicking on the images and bringing up the menu and taking a look at the interval menu. If I want to change this, let's say, for example, to 0.5 millimeter slices, I can just simply click 0.5 millimeter, and it will generate a huge number of slices because, again, 0.5 millimeter over the entire volume gives us approximately 270 odd images. But now, when I rotate or when I scroll through these images, every time I move that line, and again, I'm doing this with my scroll wheel, it's moving 0.5 millimeter through the volume. Now, a lot of people think when they use this view that they have to do exactly what I've done here, which is to basically draw the entire arch. But let's say I'm interested mostly in this tooth here. But there's no need necessarily at this time to go ahead and give me the entire panoramic arch when I'm really just focused on this particular endo problem. So what I can do is start from scratch. Delete this line by right-clicking and clicking delete. And of course, it's going to ask me, first of all, do I want to save what I've already made? In this case, no. I'm just going to get rid of it. Now, if I click my draw tool again, this time I'm only going to click on this section. Okay, this allows me to focus on what I'm interested to see. And now if I really want finer detail, maybe 0.5 millimeter is not what I want. Maybe I want it as low as I can possibly go, the voxel size. So if I right-click this and take a look at the interval, you can see 0.5, that's the lowest I can go. But if you look down the bottom, there's still a custom section. If I click on custom, I can type in whatever I want. Now, each one of our Morita volumes will have a slightly different voxel size. So how do you know what would be the correct voxel size? Well, the easiest is that we don't force you to remember that kind of thing. You just type 0. 0 will always default to the minimum voxel size. So if I click OK now, again, the panorama doesn't change, but now I'm at voxel interval, which means that every single slice that I move is now at the voxel interval. The voxel size for this volume is 125 microns. So each slice interval is 125 microns. Now, in the same way, I can modify the thickness of these slices. So if I right-click, the thickness section here shows me that I'm at 1 millimeter thicknesses. I may want to go down as far as 0.5. This will again regenerate them. And if you notice, the images get a little bit more noisy. Now this is going to be true of any data set from any manufacturer. The thinner your slices or the higher resolution of your images, the noisier they're going to become. So really, you're always trying to strike a balance between the signal to noise ratio, basically how grainy your images are, and what you need to see. Now, again, for an image like this, I would prefer usually a thickness of about 1 millimeter. This gives me a nice balance between resolution and quality, but you can always make adjustments depending on the scan that you've got. In the same way, this particular panorama, because I'm only looking at the small field, it's very, very thick. I can tell that because it looks rather blurry. So if I right click it and check its thickness, you can see it's got a thickness of 8 millimeters. This would be for a larger field pan. So I'm going to actually adjust this down to 1. Okay, and now you can see the endo problem in this particular case really, really stands out. Now, we sometimes will get questions about these particular images, and they ask us, why don't we do standardized arches? Why can't I just have a standard arch? And there's several reasons for that. One of the reasons is that we really want to give you the freedom to adjust and modify an arch to suit your particular diagnostic needs. As I showed you briefly, I don't necessarily need to see the entire arch when I'm just wanting to focus on one tooth. So in a few seconds, I'm able to click and double click and get a reconstructed pan of the tooth I'm actually interested in that is perfectly centered on my region of interest. Now, in the same way, for endodontists, we're not necessarily tied to this dental arch. Once the spline is removed and the image is just the way it's shown here, I can just left click and I can actually pull this up to be more of a patient front orientation. Okay, this is just me moving the image and basically grabbing the patient's chin and lifting it up. Okay, now this particular image may be a little difficult to understand. So what I can do is I can go back to my XYZ view. And as I said, this and the axial view are the same. And you can see that the images have changed on this side as well. So what I'd like to do is I'd like to have a look at, say, that particular problematic tooth. Let's go back to about here, okay? Again, I want to line it up. What I'm looking for in this case is one of those roots. Let's go with about here. Okay, you can still see the lesion down below. And if I go back now to my curved MPR, I'm not going to do a spline curve anymore. This time I'm going to start from the top and work my way down, double clicking. Now what I'm looking at is the axial view. So I can now work my way through these voxel interval axial views to get a really good understanding of the problems that I'm going to have to treat for this particular patient. Now again, this is most popular with our endodontists because again, you're able to see what you would normally see during treatment. So again, if I was focused on just dental arch view, then I wouldn't consider necessarily looking at it in this way. So what I want to encourage all of you to do when you're working with cone beam imagery and software that gives you this kind of freedom is to really make use of that, to make sure that you can see a tooth from every conceivable angle, because that is the power of 3D imaging. Now, I'm going to pop this back to its original orientation and show you one more thing that we can do with our curved reconstruction. Now, what I've been doing up until now is drawing splines along an axis of the tooth like this. But again, this is three-dimensional imaging and this is completely free form. I don't need to limit myself in that way. If I suspect this tooth had a root fracture, for example, rather than just do a cross section of this tooth, I might decide to maybe walk around this tooth in a circular fashion like this. And what this is going to allow me to do is it's going to allow me to see the tooth in every conceivable angle. Now, this panorama, of course, is somewhat meaningless because, again, it's a projection all the way along the edge of the tooth. So because it's kind of weird and I really don't want it distracting me, I'm just going to turn it off. So under this CMPR view, there's a panorama button, and that just hides it. Because in this case, I really don't want to see it. It's not useful to me. And now from here, I start to walk through my cross sections. Now, unlike the XYZ view, which has a single center point, this view moves that center point around, and you can see the green line shifting on my axial view. And this is not only allowing me to rotate around the tooth, but it's also allowing me to see various surfaces from many different angles. Again, I might see a small hairline fracture in one of these angles that I don't necessarily see by just a single cross section. So again, if I have a lesion here that I'm very suspicious about and I don't think it's an endo case, then I may want to do something like this to see if I can pull out a root fracture. Again, that will be useful for my own diagnosis, and it's also going to be useful for the patient when I go to explain the treatment plan to them. So now I'm just going to go back to my original contrast. I'm going to delete all of this work that I've done. Actually, before that, I'm also going to change this interval to something like I had before, which is about 2 millimeters. And very quickly go back to my contrast. Do I want to save the current state? Again, no, I don't. So working on the mandible, if I'm going to do a presentation, say for example, for the patient or for the insurance companies, I can use the printing software within our i-Dixel suite, imaging suite, to give a radiological report on this particular volume. In many cases, we need that for insurance, or we need to do that to explain to the government why we took a particular volume. So this way we can set up templates within our printing software and then just generate that report at any time. So I'm going to use my spline tool to draw a spline again. And you can see these small dots along here. Those dots allow me to modify the spline after the fact. I can just grab them, make them a little longer, adjust it as I need. And now I want to see the panorama that resulted from this. I just click on the pan and there it is. Now let's say I want to see a little more detail down here. You can see that very little information is in the apexes of the anteriors. So what I can do from here is I can right click my image and I can unlock the attitude. Now what this means is I can now manipulate this image. If I have it locked, all I can do is highlight regions of interest. Okay, but if I want to manipulate this, I can unlock it here. Now I can just simply pull up again and release, and this will slowly start to tilt the patient's head back. Now, if I'm going to do a report where I want to show this reconstruction and I want to show my axial image, etc., I can select the cross-section images that I want to show in my report by holding down the Shift key and simply dragging it across the tooth I'm interested to show. Okay, what this will do is grab each and every slice that's shown below here. The one that's visible on the screen you can see is already highlighted in blue and also highlighted in blue here on the image. It's exactly the same image. Okay, and I click on my printing button, and this will bring up our reporting software. And this is going to ask me which printing template do I want to use. Now I've set up several different templates, and you can of course create as many as you see fit. I'm going to choose this panorama and cross sections at a dimension of 30 by 40, this one here. Click OK. And you can see it automatically lays out the images for me. These empty placeholders here, this would allow me to add additional images if I wanted to. Now this one here will not show up on the printout. It's just there as a placeholder, so there's no need to be concerned whether they're visible or not. And there are options to have these automatically deleted. So now looking at this very basic report, you can see that I've added the axial image with the cross sections actually highlighted. And let me zoom in on this a little bit more so you can see it more clearly. I've got my patient name, date of birth, which is empty because this patient is just anonymous. I have comments that I can, of course, edit at any time. And I have the cross sections that I selected for this particular tooth with the endo problem. And these have been linked to the original panorama shown here. Now, of course, I can come in here and make adjustments. I can move this over, for example, and I could expand it. I can even grab all of these by dragging a box here and just moving them down. So now with my report almost ready, I can expand like this, zoom out, and then I could go ahead and print this. Now I can save it to be able to come back again by just clicking on File, Save, or I can just immediately print the image. So let's have a look at the print preview. This is what it would roughly look like. And then just click on the print button and print it to your standard printer. Now this is not just for Windows printing. Of course, if you have a DICOM printer, you can print these images directly to your DICOM printer as well. There's no limitation on that. Now, as you can see, I adjusted this size and this position because I didn't really like how it was laid out. I wanted this to look nice and professional. So let's say I certainly don't want to do that task each and every time. So on the left here, you can see these templates that I've created for demonstration purposes. The one I just selected, the panorama and cross sections, I'm just going to double click this one to pop it back on screen. Now, if you remember, what I did on the original scan here was to make this larger and to move these images down. So I'm going to go over to the template and do exactly that. I'm going to grab these images, put them down. I'm going to make this larger. And this I'm not actually going to use in this case, so I'm just going to delete it. So now I've got my CTZ, this is my axial image, my volume rendering, my panorama, and all of my other images. Now, one of the things I also did, and I'll demonstrate this in a second, was I moved this panorama over to the left. I'll show you what I mean by that in just a moment. So I'm going to save this template as a new one based on this one. We'll call this version 2. Now, version 2 is available here in my list. If I want to get back to my original scan, I just click on the 3D button. It'll ask me if I want to save this state. I'm going to click no. And here we are back at our original scan. If I want to save this and get back to this one with the spline curve, I'm going to have to save it so that when I click on the button, it'll bring me back to that particular save. So let's do a quick adjustment. Bring this down to the bone. Again, draw my spline. Okay. And this time I'm going to save it. I want to make sure that I can get back to this very quickly. So of course I can go back down to this button as I did before and click on current state. But in this case, I'm not so interested in the name. So on my keyboard, I'm just going to press Control S. That's a quick shortcut for save. And you can see saving to database. And now it'll be available next time I need it. So once again, I'm going to highlight by holding Shift and dragging across my tooth. And then I'm going to click my print button. And this time I'm going to select my version 2 template. Clicking OK will now have the images laid out a little bit nicer. But notice that this image is still shifted over to the right. I have to shift it back here. Now, of course, like I said before, I don't want to do this each and every time. So clicking on this template, I want to see what my image alignment is. Where am I actually placing my panorama image? If I right click and look at image alignment, you can see it's centered. So actually in this particular one, I'm going to align it to the left. That's where I really want it to be. That way when my image is pasted here, it's going to show up in this area. All right, it's a simple change, but it saves me more work down the road. So once again, I'm going to save it as template, and I'm going to actually overwrite my original version 2 because I don't really like it. I want to keep this adjusted one. I click Save, overwrite it, yes please. And now down below, you can see this thumbnail of the data set that I just saved. Once again, clicking on the 3D viewer will bring this up. And again, print, selecting version 2, and now you can see it's already laid out and ready to go. My goal when I'm designing a template like this is to make my job easy. Right? So the adjustment of the template I do one time, and then I create general reports for my patient or for the insurance company with a single click. If I go back now to my 3D view and I click print again, let's choose this XYZ and Vol R template. Here it's my axial image followed by my coronal and my sagittal views. Again, these are things I chose to make. I can always remove them if I decide I don't want to see these. I can just select them and delete, and they will disappear from my final report. Now, since this presentation is a little bit on how we actually use i-Dixel, I wanted to show very briefly how I would create a template like this. We're not going to go into deep details. This is just very roughly how I would lay it out. So on the left panel, or sorry, the right side of the screen here, we have several different panels. Patient data, which is all of the patient information. This will be filled in depending on the patient that you've selected. And image type over here. And you can see I've got my X, Y, and Z images. And if I scroll down even further, you can see volume rendering as well. So if I want to regenerate that particular template, I can grab my volume rendering and drop it on here. In the same way, I can grab my Z image and drop it on here. And I can do the same for Y, I can do the same for X. And then from there, it's just a simple matter of adjusting the size and the position to where I want this to be. Again, this is going to depend on your particular clinic and how you want to lay out your images. There is no right or wrong way to do it. And of course, we're not just limited to imagery that comes from i-Dixel. We can also add images like your corporate logo. In our case, obviously we're using Morita, but we can simply delete that. And we can bring up images from anywhere on our hard drive. So let's very briefly grab one from the desktop. I have an images folder that I downloaded. And let's say I want to use this logo. So I'm just going to drag and drop this on here. And now I've got a logo on my template. I can, of course, resize it, but you can see it's quite wide here as well. So what I'm going to do is I'm going to zoom in on this and I'm gonna crop this. I don't want all this superfluous information. So I'm just gonna drag and drop a box around it. And I'm gonna click on my cropping tool. And that's gonna crop my logo so that it matches my images. Now, put that in the corner. Zoom back out. And now I want to decide what to do with my images when I paste them in here. So I'm just gonna grab these and I'm gonna right click and I'm gonna say resize to template. So what that means is when I drag an image onto here or when I use this template with my images, it's going to expand or contract the image to fit inside this square. If I don't do that, my images are going to come in as one-to-one. Now that's going to depend entirely on how you want to print. You can print as one-to-one, of course, if you're dealing with DICOM, or you can go ahead and resize it more for aesthetic purposes. So I'm going to click resize for sure in this case. And then I'm going to save this as a new template. Again, using my convention from before, let's call this version 2. Now, if I go back to my curved NPR by clicking my 3D button, once again, if I press print, it gives me the option to select my new version 2 template with my new logo. Okay, and my images are laid out as I've selected. You saw that I've moved the volume rendering over to the right. In the previous case, it was over on the left. Now there's one more view that I haven't gone over yet, and that is this dual CMPR view. What this means is it allows us to draw 2 curves on a single axial image. So if I click on this now, you'll see the original axial image that came from our data set. I'm going to click on my spline tool, and like before, I'm going to draw my arch. And in this case, I have my reconstructed pan and the cross sections that go along with it. However, I can also bring up another spline from another angle. Let's say I draw this way. Now the cross sections for this spline match buccal to lingual for this particular case. So now I can look at my endodontic problem from 2 different angles within the same volume. And in the same way, I can go ahead and print these views to my report. I can create one that specifically will show me these cross sections. So if I very, very quickly select here and highlight some images that I want to show, and same here, show some images here, and click print. This time I'm going to choose this dual CMPR. Again, I set this up beforehand. I will have my images, my axial image here, and whatever cross sections I happen to select. So in this way, I can quickly build very professional looking reports without a lot of additional extra work. The work comes in actually designing my template to match my corporate aesthetics and to really show off the image quality and the images that my clinic is able to produce. Now, I'm going to go back to the home screen now, and this is going to close all of this information and bring me back to my patient list. If I was to open that patient again, I can quickly find them right here at the top of my list, because this is the most recent one I was working on. And I just want to show you briefly what the difference is in the patient folder. You can see now there's 3 additional data sets created. Now these are not copies of the original volume, which is over here. These are actually those saved states that we took. We saved the contrast adjustment first. We saved our implant placement, and we also saved this curved reconstruction, this panorama. So in this way, if I wanted to see this particular image immediately, I could simply click the 3D viewer button, and it will not only load the volume up, but it will also load that particular data set. So anytime I'm looking at this patient or this data, I'm going to select one of these saved states. Most commonly, I will choose the one where my contrast is adjusted. Now this might look a little bit different. The main reason it looks different, of course, is my histogram is available. So I'm again going to hide that so that I can look at the same view that I had originally. Now, it's all well and good to have these images on my computer, but I may want to share this with a referring dentist, and I may want to share it in a variety of different formats depending on what that doctor has in their clinic. If I want to show them exactly what I'm seeing here, we can save a version of our software, a viewer, that allows us to open this data on any Windows-based computer. So instead of saving it here as a new data set, I'm actually going to save it here, the one that says export. It's pointing to a disk, and I'm going to save the current, I'm going to export the current state. What do I want to export? The CT data. And where do I want to export? I have to choose. In this case, I'm going to put it on the desktop, and this will be remembered for the next time you export. There's nothing else you need to change in here. I press my export button, and this will export not only this data set, but also any annotations that you created and the viewer software along with it. So once this is saved to our desktop, we can take that folder and we can put it on a CD, or we can upload it to the web, and we can pass this to our referring doctor. So I'm going to just minimize this and show you my desktop here, and you can see this X700 Endo. This is the folder that it created. Inside it is what we call our one volume viewer. And this software allows me to reopen this exact data that you can see here on any Windows computer. Now this should look familiar to you immediately because this is actually exactly the same software. The only difference in this software is that it does not have the ability to save, but you do have the ability to go in and add additional annotations and measurements, and you can still, of course, adjust the contrast depending on the monitor at your particular clinic. You can see it's exactly the same as what we saved. There's no differences whatsoever. And all of those tools, including the filters, the histogram, the curved reconstruction, including the dual curved reconstruction, all of these functions are available in the viewing software completely free of charge. Again, you're not able to save it and you cannot print it, but for the referring doctor, they'll be able to see everything that you've saved and any annotations or other notes you've created in this volume. Now, if I wish, I can actually save these images out to my desktop if I want to add into, say, a PowerPoint presentation or Microsoft Word. So I'm going to take this away from full screen and just kind of place it over here in the corner. And if I right-click on these images, I can click on Copy and paste to my desktop. And as you can see, this is the same image, including the ruler, that I have reconstructed here. If I want to see all 4 of these images together, I can simply click Copy All Images. When I paste it onto my desktop, I now get all 4 of those images together. So this way I can simply copy and paste into either desktop or any presentation that I want to give in the future. So let's do a very, very quick view of another data set. This is a 40 by 80 volume, so it's a long cylinder. Okay, and you see this is our patient, and this is the data set that we took of her. Now, of course, this is not the actual patient. This is just something we've grabbed off the internet. But nonetheless, let's take a look at this particular scan. Now again, as before, first thing I'm going to do is click my log button, find my peak, find where it starts to level out, and adjust my contrast accordingly. Now again, as I said before, there is no right or wrong way to do this. Depending on the volume, you may have different preferences. To be honest, even though it's a little different than our initial endodontic presentation, I actually rather like this view, so I'm going to keep it for this particular case. So now that my contrast is adjusted, I'm going to remove this and I'm going to save this contrast. And again, I can do that by clicking this button here and saving the current state. And if you notice, Control-Shift-S is the shortcut. So I'm just going to do that, Control-Shift-S and contrast. So again, I don't want to adjust this again. Now I'm going to go to the mandible in this case, align the bone, and I can start looking through this impacted wisdom tooth case. And now you can see down here this curved root of this particular patient. Let me scroll through this a little more slowly. So when we are looking at treatment for this case, we realized that this particular root is dangerously close to the nerve canal. So I actually want to take a quick peek at the nerve canal in the 3D rendering. So I'm going to quickly draw it by clicking on my nerve tool, marking a couple points, and again, scrolling through along the nerve channel. Like so. Now, looking in my volume rendering, a little bit difficult to see the actual tooth. Am I going to have a problem here or not? So we have one more additional cutting tool which we haven't discussed. That cutting tool is our dynamic cut, this one here. If I use the dynamic cut, it will allow me to pull away the bone along this blue line. When I do that, I can now see this tooth be revealed with my nerve canal. Let me drag this here to make it larger and rotate this around so that I can see it more clearly. And now, very, very, very slowly, I want to add or remove bone to see if that tooth is starting to interfere with my nerve canal. And again, if I zoom in even more and shift my image, you can see right here that it is actually starting to interfere with my nerve canal. This would be very dangerous to just pull this tooth. This one may actually require surgery, or we may decide to actually not remove this tooth at all. So again, this volume rendering along with this dynamic cut is a good way to show the patient why you're choosing a particular treatment, or to encourage them to choose a particular treatment and be very well aware of the risks beforehand. So this basically concludes what I'd like to say for i-Dixel. So thank you very much. And at the end of this, we have a short survey, which will just allow you to give us short feedback to us, whether you enjoyed the presentation and if you would like us to make any changes in the future. So once again, thank you very much, and we'll be in touch.